Hello everyone, and again welcome back to our channel, and we will be discussing an application of derivatives of functions. Now, so this time we have a time rates problem. Now, if the value of a variable cx is dependent on time t, the derivative of x with respect to time t is the time rate of x. Now, how to solve a time rate problems? Again, we should have a clear understanding of the given situation so that we can draw figure whenever needed. So find an equation involving variables which is true for any time t. And third, we have to differentiate the equation form in and step 2 with respect to time t. Determine the required time rates from 3 using 2 if needed. So, no numerical values will be substituted until the differentiation with respect to time t is already done. For sign convention, increasing rate, assign a positive sign, and negative for a decreasing time rate. Now, we have a problem, 1, as an example. So, a kite is at a height of 70 feet, is moving horizontally at 5 feet per second away from the boy who flies it. So how fast is the cord being released when 130 feet is out? Okay, so I can start with figure as my solution. Okay, so at any time t, this is how the figure looks like. No? So this is the kite. So at the height of 70 feet, no, this is the constant height, and this kite is moving horizontally at a given rate of 5 feet per second. Okay? Now required, how fast is the cord being released? So the required is the ds dt. Okay? There's a condition given. If the cord being released is 130 feet, so which means that is a value of our s. So ds dt if s is equal to 130 feet. So what would be the equation applicable to the given figure? I have a right triangle, so I can make use of the Pythagorean theorem. Okay, so a squared from Pythagorean theorem is equal to the sum of the squares of x and 70 squared. Okay? Now, after having the equation, so we can proceed differentiating the function with respect to time t. So, the differentiation will be done with respect to time t. Okay, now, 2s ds dt is equal to 2x dx dt, constant becomes 0. So there's a common factor of 2, so I can remove, no? So the ds dt is x, correct? Multiplied with the dx dt all over s. And if s is equal to, so after differentiation, so you can now substitute values, no? So there's a value of s, which is 130 feet. There is a value of the dx dt, but we don't have the value for our s. So that's why we can, for x, so we can go back to the first equation to solve for x, no? If our s is given to be 130 feet. Okay? So e squared minus 70 squared multiplied with the dx dt all over s, okay? So s is equal to 130 squared minus 70 squared multiplied with the rate given, which is 5, and this is over 130. So calculated as 4.213 feet per second as the value of the ds dt. Okay, so that's how to answer that kind of problem. Okay, we have another situation here, or another problem where the radius of a right circular cone is increasing at a rate of 3 feet per second, while its altitude is decreasing at 6 feet per second. Now, find the rate of change of its volume when its radius is 8 feet and its altitude is 20 feet. Okay, so this is the figure for a right circular cone. So we have an increasing rate for the radius, which is 3 feet per second. Okay? And there is a decreasing rate for the altitude, which is 6 negative. Atong take a sign, which is a negative, because the rate here is decreasing. So we have minus 6 feet per second for the dh dt. Now, what is the dv dt when you are given a specific value for r and the altitude? No? So r is equal to 8 feet and h is equal to 20 feet. Now, what is the formula for a right circular cone? No, so that can be equal to, okay, so V is equal to 1/3 of the pi r squared h. Now, since there are time rates given for r and h, so we can just apply a product rule of differentiation with your r squared times h, no? So, a dv dt, when you differentiate with respect to time t, so we have a dv dt, so we have 1/3 pi as a constant, so we can differentiate the product of r squared and h. So, r squared dh dt, because the differentiation is done with respect to time t. So, h, derivative of r squared, so 2r dr dt. And then you can now substitute the condition. So, if r is equal to 8 feet and h is equal to 20 feet, dr dt is 3 feet per second, dh dt is minus 6 feet per second. So, we can now substitute 1/3 pi. So, we have r squared and r is equal to 8. So, multiplied with the given decreasing rate of h, which is minus 6, no? Plus 20 for our h, 2 times r. What's our r? That's 8, no? And the dr dt is equal to 3 feet per second. Okay, so calculated being equal to 192 pi. So, it's volume over time. So, the unit for length, no, is in feet. So, we have cubic feet or per second. So, this is now the rate of change of the volume with respect to time t, or the rate of change of V. Now, water is running out from a conical tank. So, having a dimension of 8 meters across the top and 6 meters deep at a rate of 2 cubic meter per minute. Now, find the rate at which the water level drops when it is 1.5 meters from the top. Okay, so this is the figure. So, if this is 8 meters across the top, meaning it has a radius of 4. The altitude is given equal to 6 meter, no? Okay, so this is the water level inside the tank. Okay, so we have the water level inside the tank, which is kine. So this is a variable height, and this is also a variable radius on the surface of the water. The required is the dh dt. How fast is the water level drops, no? When the water here is draining at a given rate of 2 cubic meter per minute. So, it is assigned with a negative sign because this is a decreasing rate for the volume. Okay? Now, what is the volume of water inside the tank? So, this is also conical. Okay, so that's 1/3 pi with a variable r multiplied with h. No? So, pi r squared h. Now, what is needed is the dh dt, no? And there is no rate for our r. That is why it's good to express our r in terms of h, so that our v will be expressed in terms of the required, in terms of the variable where the rate of change is required. Okay? So, r is to, this is a right triangle, and similar triangle is here also having a dimension of 4 and 6, and this is h and r. So, if I have a ratio between r and h, then correspondingly, I can have 4 is to 6. So, 4 is to 6 is 2/3. So, it's 2/3 of h being your r. Okay? Now, substitute to your v. So, it's 1/3 pi, then r squared, which is 2/3 of h. So, you can put that into square. So, the square of this is 4. The square of 3 is 9. So, 9 times 3 is 27. So, this is 27 pi h cubed. Correct? Okay. Pwede na ka mag-differentiate with respect to time t. Okay? So, dv dt is equal to 4 pi. So, over 27. So, derivative of your h cubed is 3h squared dh dt. So, if there's a given volume, rate of change of the volume, so we have minus cubic meter per minute. So, we also have 4 pi over 27, no? Times 3. So, our h is known to be 4.5 because the condition here is that ang ato karong water level is actually 1.5 meter from the top. So, it should be your h because it's taken from the vertex. So, your h must be equal to 4.5 squared, and the required time rate is the dh dt. Okay? So, calculating the dh dt can be, so it's also dropping or decreasing in height, no? So, it is also negative. So, 2 over 9 pi meter per minute. Okay, so that's the answer for the dh dt. Okay, another example na sayop, ha? Okay, a man, this is a man, na? A man whose height is 1.75 is walking away from a lamppost at a constant rate of 1.2 meters per second. If the lamp is 12 meters above the ground, then find the rate at which the shadow is lengthening, the rate at which the tip of his shadow is moving, and the rate at which his head is receding from the light when he is 8 meters from a point below the light. Okay, so what's the figure here? There is a light over here, and the man is walking at a height of 1.75, okay, away from the light. So this will cast a shadow on the ground. Okay, so this is the shadow of the man. Okay, and the rate at which the shadow is lengthening, so this represents the length of the shadow. So in A, you are required to find the dl dt. Okay? Letter B, the rate at which the tip of the shadow is moving. This is the tip of the shadow. So if the reference is here, so the tip of the shadow will be moving at a distance S, kana? So from the reference point, which is a point directly below the light, no? So ana na dia magsugod, no? As he moves away, so the tip of the shadow will actually be originating here. Okay, going there, no? So this is defining the tip of the shadow. So what is needed in B is the ds dt. The rate at which his head is, sayop niya, the rate at which his head is receding from the light when he is 8 meters from a point below the light. So if your x is 8 meters, correct? So this is the head of the man. Napabalaing ulo ning tawhana, no? Daghan ba ning o? Okay, basta gani nga o, no? So this is the distance. Receding, palayo siya from the light. Okay? So what is required in C is the dh dt. Okay? Now, how to form equation which will involve these variables, no, where the time rates are needed, no? Now, for the dl dt, okay? So, if that's that is required in A, okay, the length of the shadow lengthening, no? So, you can apply ratio and proportion, okay? So, L is to this vertical height, okay? So, L is to 1.75 to include the rate at which this man is moving. So I have to consider this variable distance of x, no? Because there is a dx dt as he moves to the right. So this is the rate of change of this distance. So we have x is to, correspondingly, we have the vertical side of Pilaman. This is 12, correct? So if that's 12 and this is 1.75, so this is a difference, 10.25. So x is to 10.25. Differentiate with respect to time t. So, dl dt, so we have 1.75 over 10.25, then times a dx dt. So, we can now substitute the value, which is 1.2 for the dx dt. So, if calculated, the dl dt is equal to 0.205 meters per second. Letter B, the rate at which the tip of the shadow is moving. So, that refers to the rate of change of your S. Okay, so if this is the side of a triangle, if I'm going to apply again a ratio and proportion, so this is corresponding to the vertical side of my triangle, which is the sum or the total height of 12 meters. Okay, so for the ds dt, I can have a ratio and proportion between S and 12 vertical side. So correspondingly, I can have the horizontal x to include, or in order to consider the given rate of change, so I have to include the rate of change of my x. Okay? So x is to 10.25. So ds dt, I can bring my 12 here. So it's 12 divided by 10.25 with the dx dt. And again, the dx dt is 1.2. So if that's calculated, then we have 1.405 meters per second. Okay? Letter C. The rate at which his head is receding, okay, sakto na eh, from the light when he is 8 meters from a point below the light. Okay, so if this is h, this is the side of the triangle at which there is a given time rate. So your h and x belongs to the same triangle. So we can apply here a Pythagorean theorem because this is a right triangle. Okay, so what would be your equation? So dh dt is needed. So x is equal to it as a condition of the problem. So by Pythagorean theorem, I can have h squared equal to x squared plus the square of 10.25. Now differentiate with respect to x. So 2h dh dt. And I also have 2x dx dt. Okay? Now, the value of x is known, and that is 8 meters. There is a dx dt. So what is missing here is the value of our h. So I can go back to my first equation. So I can solve for my h when I have to consider the given value of x, which is 8. Okay? So I can remove to simplify. And I can solve for my h by taking the square root of x squared. What is the square root of x squared? That is h squared plus the 10.25 squared dh dt, correct? And that's equal to x, which is 8, and multiplied with the rate, which is 1.2. So the dh dt will come out as 0.738 meters per second. So that answers all the required A, B, and C. Now, there's a ship moving wherein there is a time of reference. So, at non-time, there's a ship that is sailing east at a distance of 20 miles. No? So, from a point of reference, no, or origin, it moves 20 miles and then nag-change siya og course of travel, which is north 30 degrees west. No? If the ship sails 10 miles per hour, find how fast will it be leaving the starting point after 6 hours? Because 12 noon up to 6 p.m. so it takes 6 hours. No? Now, what time the ship will be nearest to the starting point? Okay, so this can be a graph. Okay, so this is the path of travel. Now, from the starting point O, so the ship moves by 20 miles and nag-change siya with the course of travel. So if this is the north direction, this is west, so 30 degrees, okay, going west from the north. Okay, so it is north 30 degrees going west. So this is now the path of travel. Okay? Now, if the ship is here and you are required to determine how fast will it be leaving the starting point, so it is actually the rate of change of this distance. Now, so you need to know what is the dS dt, no, from this side of a triangle. Now, if you have a triangle here, I have 30 degrees here, and this is all in all 90, meaning one of the angle of your right triangle is 60 degrees. Okay? So if this is 60 degrees, I have a side here, another side is here, so we have side angle side. So this is no longer an application of right trigonometry, rather this is an application of a cosine law. Okay? So using the cosine law, by the way, where did I get the 10t minus 20? The distance traveled by the ship at any time t is actually the uniform rate multiplied with a variable time. So the rate is given to be 10 miles per hour. So the distance is expressed in terms of miles. Then so we have 10 miles per hour multiplied with a variable time t. So that means the total time, the total distance after t hours, no, is actually kini. This is the total distance. So the difference of the distance, the total distance is 10 times t. Then you can subtract the constant distance of 20 before changing the course of travel. That is why we have 10t minus 20. This is the 20 miles being subtracted. So I have two sides of the triangle and one included angle. So I can apply the cosine law, because what's needed is the ds dt after 6 hours or at 6 p.m. Then what time the ship is nearest to the origin. So this condition is also an application of minima condition, no? So, is minimum or your is prime is equal to 0. Or the derivative, the ds dt is set to 0 so that our distance here will be minimum. Okay? So, again, your cosine law, can you recall? E squared equal to the square of these two adjacent sides. So, we have 20 squared plus 10t minus 20 also in square minus their product. So 2 times 20 times 10t minus 20 cosine of the included angle 60 degrees. By the way, take note. The cosine of 60 is 1 half. So if I have 1 half here times 2, so 2 is eliminated with the cosine of 60. That is why what is left is 20 with 10t minus 20. So if I'm going to simplify, maybe I can get the value for 20 squared. It's 400. Maybe I can distribute this, no? So, pwede na ma-distribute. Or okay naman siguro, ne? So, pwede na ko mag-differentiate. Okay? So, I can differentiate with respect to time t. So, I have 2 is dt. So, constant becomes 0. And according to power rule, we have 2 times the 10t minus 20. 10 is the derivative of 10t. Because this is expressed in terms of t. So, the derivative of this is 10. Minus 20, derivative of 10t minus 20 is again 10. Okay, try to simplify. I can divide with 2 in every term. So 2 is out here. This is reduced to 10. Correct? Because that's 20 divided by 2. Now, distribute. No? So we have bilang 10t minus 20. Correct? Then this is bilang. This is 100. Okay. If you would distribute your 10, I have 10t. This is 200. Is that correct? Minus 200, minus 100. So that's why we have minus 300. No? So 10t minus 300 over s. Now, at 6 p.m., no, or t is equal to 6 hours, so I can substitute my t here, value of 6 hours. Then, I don't have the value of s, so I can go back to this equation. I can solve for my s. Okay? So, the ds dt is equal to 100 times 6 minus 300. So, take the square root of their sum. Okay, so we have 400 plus times 6, that's 60 minus 20, correct? Squared. Minus 20 times 10 times 6 minus 20. Calculated, then, this will give you 5 square root of 3 miles per hour, or that is 8.66 miles per hour as the answer for A. Now, how about your letter B? In letter B, what time the ship will be nearest to the starting point? As I've said, as an application of minima, maxima minima approach, no? So, we can have the ds dt, which is a ratio of 100t minus 300 over s. So, let this ds dt be 0. So, if you set that to 0, so s is out, so we can have an equation which is 10t minus 300. So, your t is equal to 300 over 100. And that is 3 hours, no? From the start of the ship moving, no? So, it takes 3 hours. So, if it starts moving at 12 noon, so meaning the time wherein the ship is closest to the starting point is at 3 p.m. Okay, so that's all for the time rates. So thank you for watching and thank you for being with us. No? So don't forget, if you are new to the channel, to subscribe. No? Okay, so bye-bye.